Hello guys, you're welcome once again to the channel. My name is Samson and you're welcome to Chemistry with Samson. In this lesson, we are going to discuss another periodic variation, electron affinity. Electron affinity. So in our previous lesson, we discussed ionization energy, what ionization energy is, how it varies periodically on the periodic table. That is when you're moving across the period and also from the top to the bottom of a group. But in this lesson, we're going to highlight on electron affinity. When we say affinity, affinity simply means loving. Is that okay? So electron affinity simply means electron loving. That is at a basic level. So per definition, it is an energy change. That is, it can be energy released or energy absorbed when one mole of an electron is added. So the key word here is added to one mole of a gaseous atom to form a singly charged anion. So the enthalpy change or the energy change when one mole of an electron is added to one mole of an isolated gaseous atom to form a singly charged anion. That enthalpy change is what we call electron affinity. Is that okay? So, for example, if I have an isolated gaseous species, an atom or element, say X, in its gaseous form, once I add an electron to this, so the E minus we see here is the additional electron I'm adding to X. Once the electron is added to X changes to X minus. Is that okay? That is, in a basic idea in ion formation, if I have an atom X and I add an electron to this atom X, it means X has gained an electron and it's changed from the neutral atomic state to the ionic state. Is that okay? So when one mole of an electron is added to X in a gaseous form, it's changed to X minus in a gaseous form. The energy that is involved for this X to change into X minus is what we call the electron affinity. So I've written here change in enthalpy or enthalpy change is equal to EA, where EA represents electron affinity. Electron affinity is a measure or the ability of an atom to accept an electron. Is that okay? It's a measure or the ability of an atom, that is a neutral atom, to accept an electron. Please, it can't be a neutral atom all the time. It can also be an ion. Is that okay? It can also be an ion. So the ability of an atom or an ion to accept an electron. NB. Anytime a neutral atom accepts an additional electron, it experiences two things. Anytime a neutral atom accepts an additional electron, it experiences two things. That is, one, there is going to be electron repulsion. And then two, attraction from the protons. So anytime there's an addition of an electron, to a neutral atom, there's going to be electron repulsion that is going to be caused by the negative charged electrons which already exist in that atom. And also there will be attraction from the protons for the added electron. Is that okay? Another information you need to know is that for atoms that needs more than one electron, for them to be stable, they undergo what we call successive electron affinities. That is, once we add one electron to the neutral atom, it means it has gained an electron. And anytime an atom gains an electron, there is a possibility of that atom attaining stability. So if one electron is added and it is unable to attain stability, we can add more electrons until it attains stability. That is why that atom will undergo successive electron affinities. And then we will discuss that one as well. In the definition of electron affinity, I did mention that it is the energy change, and I wrote here released or absorbed. Is that okay? Anytime electron affinity, in terms of its energy change, is released, it corresponds to an exothermic process. It corresponds to an exothermic, meaning that the enthalpy change value or the electron affinity value will be negative. And anytime energy is absorbed, it corresponds to an endothermic process, indicating that the electron affinity value will be positive. So we can have negative electron affinity values and then positive electron affinity values that I will explain as well. So electron affinity is the energy change, that is the energy released or absorbed when one mole of an electron is added onto the valence shell or the outermost shell of an isolated gaseous species or a neutral atom. And once the electron is being added, the neutral or the gaseous atom changes from the atomic state into the ionic state, that is specifically an anion. Is that okay? So to form a singly charged anion, to form a singly charged anion. Is that okay? Now, what factors account for the variation in electron affinity on the periodic table? That's 1, atomic radius, and then 2, stability of electron configuration. So the factors for the variation will be 1, we can talk about atomic radius. And then 2, stability of electron configuration. With the atomic radius, we are going to break it down using the concept of effective nuclear charge and an electron repulsion, that is spinning or shielding effect, to explain how adding an electron to the valence shell of an atom will vary once you're moving across the period and you're moving from the top to the bottom down a group. Is that okay? Let's discuss that one as well.